Hello and welcome to day 19 of TryHackMe's Advent of Cyber 2. I am Tiberius and I created the task for today. It is of course a web app focused task, but I created it in such a way that all you should need to complete it is a web browser, so you don't need any fancy tools like Burp Suite, but of course if you want to use Burp, you can. So I've deployed the VM and I have the attack box running, so let's get to it. The task is called the Naughty or Nice list, and it reads, Santa has released a web app that lets the children of the world check whether they are currently on the Naughty or Nice list. Unfortunately, the elf who coded it exposed more things than she thought. Can you access the list administration and ensure that every child gets a present from Santa this year? So you can feel free to try hacking the web app on your own, or you can follow the instructions. Obviously, if you're watching this video, you probably want to follow the instructions. But if you do want to try hacking the web app, just note that when bypassing the hostname filter, use localtest.me. Otherwise, your attempts won't work. For various technical reasons, I had to kind of cheat the DNS on this box, but I won't go into that. However, just be aware of that if you are attempting it without the instructions. And don't worry if you don't know what localtest.me is, you will find out later on. So this box is vulnerable to server-side request forgery, and that's a web app vulnerability that allows attackers to force the web application server to make requests to resources it normally wouldn't. So to give an example, a web app may have the functionality to produce screenshots of other websites, right, when a user types in a URL. And that's perfectly valid functionality. However, URLs can also be made for internal IP addresses, right? So we got some examples, 192.168.1.1, or for instance, 127.0.0.1, which is localhost. And it can also, URLs can also be produced for internal only host names, so localhost itself, or this made up one like win2019serve.corp. And if a web developer isn't careful, an attacker could provide the app with these and manage to screenshot internal resources, which usually, like generally speaking, have less protections because sysadmins assume, only trusted users can access them, right? So they may have critical sensitive information that's not protected. And to counter that, user-provided URLs can obviously be checked before they're requested, just to ensure that any malicious values aren't being used. However, due to the complex nature of URLs themselves, there are often many things an attacker can actually do to bypass these checks, and this is what we'll show in this task. And actually, this is actually based on a bug bounty that I found earlier this year. So this particular bypass is in production systems. You can definitely find it out there. It's real. It's not something I just dreamt up. I did find this, and it was pretty fun to exploit. Just something else to note. So while this example of server-side request forgery is effectively a remote file inclusion vulnerability as well, not every server-side request forgery is, right? Server-side request forgery is kind of a big umbrella, and it encompasses so many other different types of attack. So some vulnerabilities will only trigger a DNS lookup. Some won't return any kind of response to like the web app, but they can still be used to kind of like port scan internal systems if you measure the time each request takes to complete. And in other cases, server-side request forgery can be used as a denial of service attack. For instance, if you can get a web app to download a large file and you can get it to do that several times concurrently, then you're taking up memory, you're taking up disk space, and obviously you're taking up network bandwidth. So let's get to the walkthrough. Once the VM is deployed, connect to the web app. So we'll do that here. I'm just going to type in the URL 177.223, and we get this page, the Naughty or Nice list, and we have two sections, the list and admin, so this will come in handy later. But for now, if we get to the list, we have a nice picture of Santa there. He says, welcome children. To find out if you are currently on the naughty list or the nice list, please enter your name below. Have a Merry Christmas, ho ho ho, Santa. Okay, so let's enter a name and see what happens. We're going to enter Tiberius. Obviously, you can enter any name you want. It's going to refresh the page, and when we scroll down, it's going to say Tiberius is on the nice list. And depending on what you type here, it should change between nice and naughty list. I kind of want to leave it as like a bonus point, I guess, the first person to figure out what I'm doing. There is some logic that's happening when you type in a name, how it calculates whether that person is on the nice list or the naughty list. It's pretty simple, not too tricky, but if you can figure it out, let me know on Twitter. But if we also notice when we type the name in, click search, it did load the page, and now we have this proxy parameter in the URL. But we can't see what the entire URL is, so I'm going to copy it. We're going to go to Sublime Text and paste it. And we see it's got, this proxy parameter, and it's set to what looks like a URL. Obviously, this is all URL encoded, ironically. So what we're going to do is just copy this part. I'm going to open a new tab, click Offline CyberChef. CyberChef is a fun tool you can use to encode stuff or decode stuff. So we'll paste it in the input, and then we're just going to go to, this is the favorites menu, it should already be open. If you double click URL decode, it's going to run that, and this is the decoded output. So I'm going to take that and we'll put it back into Sublime. So this proxy parameter is passing this value to the application. It's basically a URL that goes to list.hohoho on port 8080 with the path /search.php, and it passes the name as Tiberius. So list.hohoho is not a valid host name on the internet. As far as I'm aware, .hohoho is not a top-level domain. You can't just go and buy a domain that has .hohoho. So this hostname likely refers to some back-end machine, because if you control the environment, you can set the domain for that environment, as long as you have a DNS server at the back end that understands that this is the domain, right? And it can resolve domains with this sort of top-level domain. So it seems that this web app that we're dealing with is taking this URL from the proxy parameter, it's making a request at the back end, and then it's returning the result to the front-end web app. And the result probably is whether the user is on the nice list or the naughty list. And so if the developer hasn't been careful, we might be able to exploit this functionality using server-side request forgery. So we'll move on to step 3. The most obvious thing we can try to do is fetch the root of the same site, right? So currently it's fetching search.php with the argument name equals Tiberius. So if we select all this, delete it, and delete that S, so all we have is this %2f, which is just a / encoded. If we hit enter and scroll down, now we get this not found. The requested URL was not found on the server. So this obviously looks like a generic 404 message, right? And so that indicates, we were able to make the server request this modified URL that we passed, and it returned the response. And there are many things we could do now. So we could try to find valid URLs for the list.hohoho site, right? So currently we know that search.php is one, but we could try and find other sites, other pages. But we could also try changing the port number. So currently it's set to 8080. And so we can see if there's any other ports that are open, or if we can even access some other ports. So let's try changing the port number from 8080 to just 80. And we will hit enter again. If we scroll down, we get failed to connect to list.hohoho port 80, connection refused, right? So that suggests that port 80 is not open on list.hohoho. So let's try another common port, 22, which is obviously SSH. And if we scroll down now, we see we get a receive failure, connection reset by peer. So that actually suggests that port 22 is open, because it wasn't the same as the connection refused message. And the reason we get this different response, even though it's an error, is because effectively what's happening is the web server is sending an HTTP request to the SSH server on port 22. And the SSH server doesn't understand HTTP, so when it gets the HTTP request, it's not going to process it, it's just going to reject the connection and effectively reset the connection, right? So that's why you get that different error message. Enumerating open ports via SSRF can be performed in this manner, so you can iterate over common ports, measuring the differences between the responses. So in this case, these were the error messages were produced. But even in cases where error messages aren't returned, it is often possible to detect which ports are open and which ports are closed by measuring the time each request takes to complete. So often I found that if a port is closed, the time that the request takes to complete is longer. And that's because of things like timeouts. So if a port's open, it will respond quicker. But yeah, that's something you can test in Intruder, in Burp Intruder, if you want to. So if we go to step 6, another thing we can try to do with SSRF is access services running locally on the server. So we can do this by replacing list.ho-ho-ho hostname with localhost or 127.0.0.1, among others. So let's try that. So what we're going to do is take list.ho-ho-ho, all of it out, including the port number, and we'll put localhost. And let's scroll down. And it says your search has been blocked by our security team. And indeed, if we try other host names or IP addresses, so if we try 127.0.0.1, and scroll down, it says your search has been blocked by a security team. We'll try one more. We'll try, for instance, example.com, right? And if we scroll down there, we say, yeah, your search has been blocked by a security team. These are all being blocked. So the developer has clearly implemented some kind of check, but we do know that list.ho-ho-ho works. So we can try and think why this might be working, and actually it turns out effectively if we just type something, anything there, and press enter, we'll get this error. So this is an error message. It's not being blocked by the security filter, but it's just saying it couldn't resolve this host. And so this kind of gives a clue of what the check is. All the developer's doing is checking that the host name starts with list.ho-ho-ho. Doesn't matter what comes after it. As long as it starts with list.ho-ho-ho, it's going to be allowed through. It's not going to trigger that security check. So this is basically what the end of part 6 says. Developer has implemented a check to show the hostname provided starts with list.ho-ho-ho and will block any host names that don't. So as it turns out, this actually can be pretty easily bypassed. Since the hostname simply needs to start with list.ho-ho-ho, we can take advantage of DNS subdomains, and we could create our own domain, right? We could create list.ho-ho-ho.evilsite.com if we owned evilsite.com. And we could set that up to resolve to 127.0.0.1, which is localhost. That's perfectly legal in terms of DNS. You can do that. But in fact, we don't even need to buy a domain, right, or configure a DNS, because there are multiple domains already that exist that let us do this. And by us, I mean testers, hackers, sysadmins. If you need a domain or a subdomain to point to localhost for some reason, there are sites that do this. The one we're going to be using is localtest.me, and this resolves every subdomain to 127.0.0.1. So I'm just going to reload that. So let me prove that. So if we go to the terminal, we'll use the host command. If I type in localtest.me, we see localtest.me has address 127.0.0.1. If we put tiberius.localtest.me, that has 127.0.0.1. And if we put literally.anything.localtest.me, that also has 127.0.0.1. So every subdomain of localtest.me, apart from I think readme.localtest.me, which hosts their website, resolves to 127.0.0.1. So if we go back to this site, now what we can do is we can modify the URL and just add .localtest.me. And once this loads, if we scroll down, we get this hidden message, which is clearly on some local site on the web server. There is a web server running on port 80 locally to the machine, bound locally. Nothing else can access it. And it has this message displaying, Santa, if you need to make any changes to the naughty or nice list, you need to log in. I know you have trouble remembering your password, so here it is. Be good for goodness sake. Signed Elf McSkiddy. So I think if we scroll down, what is Santa's password is the first answer. I'm not going to copy because copying from this is kind of tricky, so I'm just going to type it in. And remember the exclamation point. If I submit that, we get correct answer. Great. So now we can scroll down even further. Number 8 says, click the admin link at the top, we'll scroll down. To log in, guess the username and use the password you found. To log in as Santa, there's a clue there as to what the username is. It's just Santa. And password be good for goodness sake, exclamation point. And if we click login, I'm not going to save that. We get to the list administration, the admin.php page. This page is currently under construction. Only press this button when emergency levels of Christmas cheer are needed. So let's delete the naughty list. And we get this challenge flag, THM for try hack me, and then everyone underscore gets underscore presents. And if we submit that, that is the correct answer. And so yeah, that's the room. It's pretty simple, but hopefully it teaches you about the basics of SSRF, some techniques for bypassing domain restrictions. I do say, yep, this bypass was actually used in the bug bounty. So yeah, I really hope you enjoyed this. Please consider giving me a follow on my Twitter, which is at Tibsec, my Twitch, which is also Dibsec, and my YouTube, which I actually got Tiberius for the username on that. And I also sell 2 OCP Privis courses on Udemy. Coupons for both can be found on my Twitter. And I have also free Windows and Linux Privis rooms for free on TryHackMe as well. So if you want to check those out, those would be great. I definitely recommend these 2 rooms. They are absolutely free. You don't have to have a TryHackMe subscription, and they'll walk you through some of the common Privis techniques that you'll need really for the OSCP, and also if you're going to become a pen tester. So yeah, really hope you enjoyed the room. Have a very Merry Christmas.